third session in the publication writing series, and we are joined today by Adam Brentnell and Tom Hamburg, both from the Centre for Evaluation and Methods. And ahead of this session, Adam and Tom both pre-recorded a video each on presentation of data and then on common statistical mistakes in health research publications. One of those videos we got out to you only this morning, so I was going to do a quick poll as to whether we go straight into Q&A, because most people have watched the video or have a good sort of foundational knowledge, or whether we watch a bit of the video first in this session and then go to the Q&A. So I'm just going to put in the chat a Mentimeter. So if people go to mentimeter.com and just fill this, I don't know if I can do this in Teams, so I'm doing it in Mentimeter. Just let me know which of those is your preferred options, because we want to make it as sort of pitch at the right level based on whether people have watched that video or not. And perhaps Adam can introduce his competition alongside while we wait for that poll to come in as well.
Yeah, so a bit of fun. If you'd like to win a book on medical statistics by Martin Bland, then please generate a mem and post it in the chat. And the rules of the competition are that your mem should be something about what Tom and I presented. So I've got one that I've put in the chat. There's an example where somebody gets thrown out of a window because they want to do a 3D pie chart. The winner will be the person who gets the most likes. So do like and vote up the mems that you think are good.
Thanks, Adam. We've got some votes coming in. It's looking worryingly sort of balanced at the minute, but no, actually one's just pushing into the lead. Had nine out of 35 people vote, so give another minute. People are just sort of struggling to get on to the website.
While people are voting, maybe I could quickly say I got an email from somebody requesting access to the video. So that's on the QMUL, my video is on the QMUL SharePoint. And in order to access that, you need to use your QMUL account. So it doesn't work with an NHS.net account or something like that.
Right, it's completely split. We've had there's just a little bit of additional preference to watch 20 minutes of the video and then do the Q&A. Yeah, that is the preference, even though it's a little bit there's sort of quite a lot of votes for the other one as well. But yeah, that's definitely the preference. So if we do that, if we watch 20 minutes, which is basically points 1 to 5, which is the majority, it's quite a good foundation then, isn't it, Tom? And then we can launch into Q&A for both of the videos. Does that sound okay?
Yep, maybe those who don't want to watch the video can do a mem.
Shall I share, or do you want to share?
If you've got it open, do you want to share, Tom?
Do have it open, but let's see how this goes. One, I think.
Yep.
Can you see the screen?
That looks good.
Okay.
Yep.
Let's go.
I guess you could also post questions in the chat as you go as well, and then we can.
Yeah, that's a great idea.
There's no sound on mine.
No, there's none on mine.
You can't hear the sound.
No, I think there's something about enabling audio.
You know how these things work, Tor? Maybe it's easier if you share.
No, I don't. I don't know how to share a video over Teams. I'm just Googling it though. Sorry everyone for these technical issues.
But whilst we sort this out, if you do have a question, it's probably a good time to ask it.
There's something. Put something in the chat, Tom, for troubleshooting. I think it's in Teams rather than in SharePoint, where you have to make to say enable sound when you're sharing.
Okay. Am I still sharing, by the way?
Yeah.
Sharing. Up here. Okay, that should be, back here in this presentation. I'm going to talk about. Did you hear something now?
Yeah.
Yeah. Okay. Sorry about that. Let's go. My top 10 common statistical mistakes in health research publications and how those can be avoided. And this presentation is complementing Adam's presentation, who talked about good presentation of results in journal articles and the importance of reproducible research and using reporting guidelines. I'm starting this presentation where many presentations finish, which is with the references and also a disclaimer. In this talk, I'm going to describe my personal top 10, which is a combination of things I see when I review articles as a statistics reviewer, as well as mistakes, which I think are most impactful. None of these are particularly novel ideas. They've all been described somewhere else. For example, in these 4 references I have on the slide. So the first one is an excellent article by the BMJ statistics editors, where they describe 12 mistakes they often see in submissions to the BMJ. The second article is also a top 10 list. However, what the title doesn't mention is that all the examples in this case are from neuroscience, which is the area where the researchers work in. The third and fourth item are very extensive collections of statistical mistakes people make in publications. Not all of them are in the medical sciences, but many of them are applicable to the area we are working in. The first problem I'll talk about is omitting an appropriate comparator when the aim is to assess the effect of an intervention. Why is the control group important? Because judging the effect in isolation fairly is very difficult. How would we be able to know that the intervention caused an effect and it wasn't the result of other factors that would have happened even without the intervention? Here's an example which illustrates this problem. Suppose we have a novel training and we want to assess the effect of this training on the leg strength of athletes, and this is assessed through a specific exercise test, which is conducted before they started training and after they've completed training. Now, when we are repeating the same task in the absence of an intervention, this might induce a change in the outcomes between pre and post-COVID measurements. For example, due to participants or the people assessing the participants becoming more accustomed to this particular experimental setting or test. And there could also be all sorts of other changes relating to the passage of time, additional training that participants do, or changes in their diet, for example, that improve their leg strength. So if the experimental design doesn't allow for the separation of the effect of time from the effect of the intervention, then the conclusions regarding the impact on the event of the intervention should be presented as tentative. So when your aim is to assess the effect of an intervention, whenever possible, you should include a comparator. And ideally, this comparator should be identical to the experimental group where you're assessing your novel intervention in all respects apart from the intervention itself. How can this be achieved? Well, ideally, the best way to do this is randomization, conduct a trial. However, this might not always be possible. So when you can't conduct a randomized experiment, you might still be able to have concurrent controls from somewhere, and clever methods exist to compare these as fairly as possible against your intervention group. And if you can't have concurrent controls, you should at least try to have historical controls. Whenever there's an experiment journal publication which I'm assessing and there is no control group, and I think a control group would have been possible, that rings alarm bells for me. And if you're writing your paper, you should always justify why you have chosen a certain control group if you're not randomizing. And in particular, you should justify if you don't include a control group and reasons why it hasn't been possible in this particular case. The next mistake I'll talk about is making judgments of differences between groups without direct comparison. And I should have said at the beginning, most of my examples come from clinical trials because that's the area I work in and have most knowledge of. So suppose you have two groups, an experimental and a control group, and you want to say something about whether these groups are different in some particular measure. What's the mistake that people might make? Well, for example, look at the right-hand side at the figure there, which shows differences between pre and post assessment for an intervention group and a control group. And if you look closely, you can see that the confidence interval for the group on the left-hand side is just above 0, whilst the other one is overlapping 0. So some people might say, well, the difference in one group is significant, whilst the other one is not. Therefore, there's an effect in the left-hand side group, whilst there isn't one on the right-hand side. Obviously, if you look at this figure here, you see how ridiculous this is in this particular case. The point estimates are almost identical, and there's virtually no difference between these two groups. However, without a figure visualizing the data, this problem might not always be so obvious. So here's a fictional example, and apologies, some of my slides are a bit text heavy, but the nice thing about recording this presentation is that you can pause at any time, just read a slide and then continue. So I'm not necessarily going to read everything out. But in this scenario, we have an experimental group and a control group, and in the experimental group, there was an average improvement in the outcome of interest from baseline to follow-up of 3 points, which happened to be statistically significant. And then there was a placebo control group where the outcome of interest improved on average by 2.1 points. And this improvement within group change was not statistically significant. Now, since the comparison group was a placebo and not statistically significant, somebody might reach the conclusion that the intervention, fish oil, is beneficial for improving cognitive function, the outcome of interest here. But this conclusion would be inappropriate and in this scenario here wrong. Whenever you want to say something about a difference between two groups, you need to make a direct statistical comparison between these two groups. And in the fictional scenario here, the average between group difference is what you're really interested in. And this is 0.9 points and not statistically significant. So the example I've given here is perhaps not as common nowadays as it once was, but the same situation or a similar situation arises in subgroup analysis, where I think it's still more commonly that subgroups are reported as treatment effects within each of the subgroups, and then people make judgments based on whether these effects within subgroups differ, perhaps whether the confidence intervals around particular subgroup treatment effects overlap or not. This, again, is an inappropriate analysis. If you want to make a comparison or say whether the treatment effects differ by subgroup, the appropriate analysis in this case would be an interaction test and making judgments on the magnitude of this effect. The next problem is the analysis of change of baseline measures. There's nothing wrong with analyzing change of baseline per se. The problem is how it's often done. So what people might do is say there's a variable of interest, which is measured at baseline and post an intervention period, and people take the post variable minus the baseline variable, take this number, compute that for everybody in the intervention group and control group, and then you're comparing these change measures between the two groups. Now, that's not a very good idea because this sort of analysis actually requires several assumptions to hold. One I've put on the slide is that this variable shouldn't have any floor or ceiling effects. Another one is that it's problematic if this variable has also been used as an inclusion-exclusion criterion, because then there will be a strong regression to the mean effect. And there are more powerful alternatives to this analysis. And the worst type of change from baseline measure people can do, which should strictly be avoided, is looking at the percentage change from baseline, because that's actually an asymmetric measure for which standard statistical methods aren't appropriate, and which can lead to some very strange results if used naively. So I've put an example here where we have one participant who increased on a variable from 1 to 2, so that's a 100% increase, and another participant who decreased from 2 to 1, so the same magnitude of effect, but a decrease from 2 to 1 is a 50% decrease. Now, if you average that, you should really have an effect of 0 change. However, if you average 50 and 100, then you end up with a 25% simple average, which clearly doesn't make sense here. A better approach would be to use the suitable regression model with the follow-up measurement as the outcome and covariate adjustment for the baseline value. This would be a more powerful analysis than the change of baseline analysis described on before. And indeed, it would also be more powerful than an unadjusted analysis if the baseline value is prognostic of outcome, which in most cases it will be. This analysis also requires fewer assumption, although it does require some assumption. And I think it often also better matches the research question people are actually interested in. So with this regression model, what you are assessing is if there are two participants with the same baseline value, and one is given treatment A, one is given treatment B, will they tend to have different follow-up values? Next is missing data. And the first thing to say is that in all real-life research, there's missing data. The question is not whether there is missing data. The question is how much and why do we have missing data? And when I'm reviewing articles, not acknowledging the completeness of your data and not quantifying reporting on the missingness is a clear red flag. So that's something that should always be done when writing an article. The next thing is how do you handle missing data? And an approach that people sometimes might take is that they exclude all participants from a study who have some missing data. So that might be called a complete case analysis. That generally isn't a good idea, because it's not making very efficient use of the data you have collected. So you're reducing your statistical power in your analysis, you have less precision, you're just not using your data as efficiently as you could be, and it will often also lead to biased estimates, in particular in observational studies, but also in trials. So a better way of analyzing accounting for missing data is replacing the missing values in your analysis with some made-up imputed values. And one method, which I'm sure most of you will have heard of, is using something called multiple imputation. And just very briefly, what that does is it replaces a missing value with a computer-generated value. And these values are generated based on certain rules plus a random component. And you do that so you get a complete data set, you estimate your quantity of interest, and you do that several times and then average over the effect of in each of these data sets. So that's one very flexible method that can be used and should be used in most scenarios. Another method which sometimes can be used is using mixed methods or mixed models, which implicitly impute missing values in certain scenarios. And when you have trials where you randomly allocate participants to groups, it can also be appropriate to use simpler methods than multiple imputation, something like mean imputation in certain scenarios. But if you use multiple imputation for your missing data, it's, as I said, a flexible approach and can generally be applied for all scenarios we're interested in. The next mistake that people could make is that they're using sample sizes which are too small. We all know how hard it is to conduct large experiments. It costs a lot of time, money, and effort, but using small sample sizes can be problematic for producing robust results as well as subsequently getting your research published. So the first and obvious problem with a small sample size is that you have a low power, which means you are more likely to miss a relevant. I'm stopping here because we're running out of time for this, and I would quickly like to highlight the last point. Let's see if I can do this. So point number 5 was basically, please justify your sample size and, if possible, conduct a sample size calculation. But the last point, if I can find it, is a bit of a summary point. Where is it? Yeah, sure. Which I think is important. So I thought I'll quickly play point number 10 as well. Difficult to replicate. So here's the final item of the top 10 list of statistical mistakes to avoid when writing journal articles, and that is not consulting journal guidelines. When you go to the submit a new article page of journals, they will usually have submission guidelines. And if you look at these 3 submission pages of these 3 journals I've put on the slide here, where we would probably all like our research to be published, they have very extensive guidance on statistical issues as well. If you look at this guidance, and if you also think about the issues that I've raised, you will notice that many of the statistical problems are not actually occurring at the write-up stage when you're writing up your results. They occur earlier on during the design stage. And to some extent, if the first time you look at journal guidelines and think about your submission is when you're writing up the results, then it's already too late. If you have chosen an inappropriate design or a sample size which is too small, these things are very difficult to fix at this point. So what I really mean by this mistake is I would suggest you consult requirements of the top journals given here when you start thinking about your study. And if you have experienced collaborators, they might do that, might very well do that for you. But it would be a good idea to already think about the publication when you're designing your study. And the BMJ in particular, they're very specific on their submission page about research that they won't publish. So they say, for example, for interventional studies, we won't publish studies that don't include an adequate comparator. We won't publish studies which are not sufficiently powered and don't report a sample size calculation. To summarize, I hope I've okay, let's stop here. I think I stopped sharing.
Yeah, brilliant. Thanks, Tom. So that gives us about 15 minutes for any questions on what we've just heard or on the pre-recorded presentation that was sent out from Adam earlier this week, or any questions that anyone has about something current in a publication that they're writing, whether it's sort of about presentation of data or about the sort of writing the statistical section. So I think people just, we've had some great memes coming up in the chat, just to acknowledge those as well. But yeah, just put any questions in the chat or raise a hand, and we've got two expert statisticians here to kind of answer any questions that are arising. Marta.
Hello, I would like to ask about the point that you made about data imputation. So if the imputed data doesn't have the same distribution as the original not imputed data, so for example, it's a bit more centered toward the median, can it still be used? And also, when producing the estimates from the data that was not imputed and then using the mice and producing the pooled estimates from the data that was imputed, and these estimates are different, which one should be chosen? I mean, you're saying that the one that has not been imputed can produce the biased estimates, but then shouldn't they be relatively similar if the imputation was correct? So that's about something I consider for publication, and I'm actually not sure if the data imputation is a correct approach, but it seems to be that most of people would recommend doing it just because it can be done. Could you advise, please?
Have we lost Tom? Is he ducked out?
Oh, sorry, maybe it wasn't a good first question.
I think perhaps a connection issue. I don't know. Is that one to wait, Adam, or do you have a response?
Tom says Teams has crashed. He's back in a second.
Okay, let's wait. I wonder how much you heard of your question, Marta. Perhaps do you want to summarize it in the chat as well? And then if anyone else has oh, he's back. Hi, Tom.
Hi, sorry about that. My work laptop Teams keeps on crashing. I need to handle it, I think.
Did you hear much of Marta's question before you got before you went out?
Only the beginning. It was about imputation, wasn't it?
Yeah, I can quickly repeat it. I think I'll say it faster than type it. You've said that the imputation is, my understanding was that it was a recommended tactics. But how to proceed in the situation if the imputed data doesn't have the same distribution as not imputed data? So it's, in my case, it's closer to the middle of distribution. So it didn't impute a lot of extreme values, the smallest and the biggest. And then if producing the estimates from the model without imputed data and producing the pooled estimates from, let's say, 5 models with imputed data, these estimates are not the same. So the models are overall not similar. Does that mean that imputation failed? And which estimates should be chosen, the one from not imputed data or the ones from imputed data?
So I don't think it means that the imputation failed because the estimates are different. I think to some extent it would be surprising if this isn't the case. It's a bit difficult to say what's going on here without knowing more details. What sort of imputation method did you use? I mean, there could be problems with the method or the type of outcome you were using. But I think having different estimates for the complete case and the imputed analysis is doesn't mean that something is wrong. That's to some extent why we do this type of analysis. We want to see the sensitivity of your analysis to missingness. Did you just do a simple missing at random imputation, or were you doing some missing?
Mice for ordinal data. So I wonder, should you publish 2 and say, well, these are my estimates from not imputed data, but I tried to impute, and they are different?
So, I mean, ordinal data can be tricky in imputation methods. That always causes problems, actually. I think, I don't know what sort of study you were running, but as I said in my talk, I think in most cases the analysis imputing data would be more appropriate than what I think you're referring to as the other analysis, which is just using the complete data analysis.
Yes,
what's your
yes.
view, Adam?
Yes, complete analysis means the other data. Okay, thank you very much. Thanks.
I think no one's asking questions because they're all frantically making memes in the background here. I don't even, they're getting more and more complicated. Do we have any other questions? Anything on, I don't know how many people were able to watch Adam's talk ahead of the session, but anything on sort of presenting data in tables? Any questions you might have? Probably.
I can summarize my talk if you like.
Quick
It
summary.
will take 30 seconds probably. Firstly, use reporting checklist to make sure you report everything. That saves you 10 minutes. My talk. Secondly, don't use 3D charts. Make sure your charts are simple and they're telling a story. Same for tables, really. And don't use lots of lines, write line numbers. Think about trying to have the table and chart so they stand alone and you can read it without reading anything else. And the third thing was to try to make sure your research is reproducible when you do your analysis by using things like computer languages where you can write your analysis as a script so you can run it again. Don't use SPSS. That's it.
Thank you, Adam. Wonderfully succinct. Any questions? We've got another, well, we'll have to do the judging of the memes. We'll leave a couple of minutes at the end, but we've got at least sort of 5 minutes of questions. Kim.
With presenting graphs, does it matter what color, or does the journal usually just change the color of your graph anyway?
That's a good question. It depends on the journal. So some journals will charge you if you use color.
Oh, okay.
So you don't want to use color or have it so that you use grayscale, for instance, whereas other journals, they encourage you to use color because it's more helpful. If you're using color, sometimes things like the default colors that R uses for its standard graphs, for instance, aren't very good for colorblind people.
Okay.
So you may want to think about that.
Okay.
What was your question? I've forgotten.
No, I'm just like wondering what color is best to use, or yeah.
Yeah, so I'd say in general, try and make it so that if it is in black and white or it's in color, it's still readable.
Okay.
And if they let you use color, use the colors that help you see what's going on and help everyone see what's going on by trying to take into account things like color blindness.
Okay.
There are special palettes that you can use for that sort of thing.
Okay. Thank you.
Thank you.
I hope I'm saying this right. Nefeli?
Yeah, I think on the same note with the colors, is there a particular font or that is considered best to use?
Is there a font that's considered best to use for graphs? I don't know, but what I was taught was that if you got a choice, sometimes you don't have a choice, do you? If you've got a choice for your text, you should use something which is, I can't remember which way around it is. Is it sans serif and serif are the two ones? So Times New Roman is better, for instance, for writing in a paragraph, and something like Arial is better for a chart, I think. I can't remember what they're called, but what do you think, Tom?
Yeah, not sure, to be honest. Follow the journal guidelines.
You don't often see Times New Roman in a chart, though. The defaults they give you tend to be the sort of, I guess it's sans serif, are the little things they put on the characters, the serifs? I don't know.
Yeah, I think it is sans serif.
Probably got time for one or two more questions. One long question, two short questions. If anyone else has got anything.
Got 5 minutes for a mem to beat Nefeli's, who's winning at the moment.
The people's choice so far, yeah.
I'll say something which I might regret, which is for this session, we were thinking maybe people want to send in their results presentation or statistics paragraphs, and then we can discuss them here, make suggestions for improvement. Just in case you have an article but just didn't have enough time to prepare it for this session, please feel free to share it within the next week. Let's say it. I'm happy to have a look if anybody has anything.
Thanks, Tom. That's great. It looks like we don't have any more questions. And that's, in the last moment, Marta.
Well, if nobody asks, then I'm going to ask another question. I'm going to ask about the concept of including the variables that affect outcome and exposure and multicollinearity. So if we think that some variables conceptually have the effect on our exposure and on our outcome, and so I think they should be included then, but we include several variables and they are multicollinear. Should we include all of them? Should we select only some of them? Should we just ignore multicollinearity and think if this is the variables that we conceptually assume are important in our analysis, they should all go in?
So I'm guessing you're talking about an observational study of some
yes,
kind.
I'm talking about always.
Always, okay. So multicollinearity is a problem, and I'm not an expert in this sort of analysis, but I would say you want to, there's something that should be avoided, and you want to pre-specify. It's always good to pre-specify and write your analysis plans. Say which variables you want to include. And as you said, conceptually, I would probably look at the variable to have variables where you think this isn't a problem. So for each of the concepts that you think affect outcome, pick one variable and pre-specify them, and then additionally pre-specify your strategy for excluding or including variables. Well, probably not excluding variables should you run into any problems, convergence problems or something like that.
Okay, thank you very much. Thanks.
Brilliant. So we will wrap up there. So it looks like there has been, oh, Hiro, is it a very quick question?
Yeah, thank you. Tom, is there any statistic test for finding the if our missing value is missing not at random?
I'm not sure there's a test. I think there's not something you should test, really. It's something you need to think about, whether missing at random is a plausible assumption or not. You know, you can never know whether a variable is missing at random or not at random, looking from the data. You can just make different assumptions and use different imputation strategies, missing at random, not at random, and then perhaps see whether the estimates are consistent, and that gives you some clue of about the missingness as well. But this is not something you should test. You should think about reasons for the missingness of your data rather than doing a test here.
Thank you.
Brilliant. Now we'll wrap up. So thanks very much to Adam and Tom for their time, both doing the pre-recorded videos, which will be available and on the staff zone as well. And thanks to everyone for coming. And the next session in this series will be 7th of December, where we're demystifying the editorial process in terms of publications. So yeah, brilliant. Thanks everyone, and see some of you there.
Thank you. Bye.